Could the alien planets of TRAPPIST-1 host life?
Section 51.
Section 51.
Section 51.
Hi everyone, what's up? I am GH, aka DOZgeek. It's nice to be back here with you on Section 51. Thanks for meeting me on this channel every week. Now, let's go on an interstellar journey. Let's go deep in space. As you certainly know, the year 2017 featured one of the most remarkable exoplanet discoveries in recent memory. A total of 7 Earth-sized planets have been found orbiting a cool dwarf star, 3 planets of which are in Goldilocks orbits, meaning they could have conditions right for life. And today we are gonna talk about one of 7 planets orbiting this small star, TRAPPIST-1, which may be capable of supporting life as we know it on Earth. Located 39 light-years away from Earth, TRAPPIST-1 is a relatively cool M-dwarf star with about 9% the mass of Earth's Sun and about 12% its radius. This ultra-cool star is believed to host at least 7 rocky planets that are about the size of Earth or smaller. A red dwarf or M-dwarf is a small and cool star on the main sequence of M spectral type. Red dwarfs range in mass from about 0.075 to about 0.50 solar mass and have a surface temperature of less than 4000 Kelvin. Red dwarfs are by far the most common type of star in the Milky Way, at least in the neighborhood of the Sun, but because of their low luminosity, individual red dwarfs cannot be easily observed. From Earth, not one is visible to the naked eye. Proxima Centauri, the nearest star to the Sun, is a red dwarf, as are 50 of the 60 nearest stars. According to some estimates, red dwarfs make up 3/4 of the stars in the Milky Way. Using terrestrial climate and photochemistry models, researchers from the University of Washington simulated environmental states for each planet of the TRAPPIST-1 system. The models show that all 7 exoplanets likely evolved like Venus, meaning that any water or oceans would have evaporated early on in the system's formation. According to these models, the 7 planets of TRAPPIST-1 would have dense, uninhabitable atmospheres. However, one of the worlds, called TRAPPIST-1e, may host liquid water on its surface and, as a result, be able to support Earth-like life. TRAPPIST-1e lies in its star's habitable zone, the distance from a star at which a planet is warm enough to have liquid water on its surface and thus potentially support life as we know it on Earth. Researchers said that this planet may also have a lot of oxygen. As water evaporates from a planet's surface and is zapped by a star's ultraviolet emissions, the hydrogen and oxygen molecules split. The hydrogen can be light enough to leave the atmosphere despite the planet's gravity, but oxygen will linger. Therefore, TRAPPIST-1e could have a thick oxygen atmosphere formed through processes that are far different from anything yet observed. 2 other exoplanets of the TRAPPIST-1 system also seem to reside in the habitable zone. TRAPPIST-1d rides the inner edge of that zone, while farther out TRAPPIST-1h orbits just past the outer edge of this Goldilocks-like region. This is a whole sequence of planets that can give us insight into the evolution of planets, in particular around a star that's very different from ours, with different light coming off of it. M-dwarf stars are very different, so you really have to think about the chemical effects on the atmospheres and how that chemistry affects the climate. Models of the star's radiation and chemistry demonstrate the possible spectral signatures of gases in its atmosphere. Using this data, researchers can better predict where to look for such gases in the atmospheres of exoplanets, using the James Webb Space Telescope, which is expected to launch in 2021. Astronomers will use the observed bumps and wiggles in the spectra to infer which gases are present and compare that kind of observation to say something about the planet's composition, environment, and perhaps its evolutionary history. In addition to the potential habitability of TRAPPIST-1e, the models also suggest that TRAPPIST-1b, the closest planet to the star, is too hot for even sulfuric acid clouds of Venus to form. TRAPPIST-1c and d receive slightly more energy from their star than Venus and Earth do from the Sun, and, as a result, have dense, uninhabitable atmospheres. Also, the outer planets TRAPPIST-1f, g, and h may be frozen worlds, depending on how much water formed on the planets during their evolution. The processes that shape the evolution of a terrestrial planet are critical to whether or not it can be habitable, as well as our ability to interpret possible signs of life. Researchers believe that we may soon be able to search for potentially detectable signs of these processes on alien worlds. But recently, a curious discovery emerged. The largest of the worlds in the 7-planet TRAPPIST-1 system, we talk about TRAPPIST-1g, this planet boasts an atmosphere that has evolved over time rather than the one that formed with it. Observations made with NASA's Hubble Space Telescope reveal that the planet's atmosphere is different from its nascent environment, meaning it's most likely a rocky world similar to others in the system. Anna Wakeford, a researcher at the Space Telescope Science Institute in Baltimore, Maryland, told that its atmosphere is not the one it was born with. A natal atmosphere would be rich in hydrogen, which the researchers don't see. Instead, it's been changed by different processes. Atmospheric and geological activity could have played a significant role in the changes. She presented the results in January 2019 at the winter meeting of the American Astronomical Society in Seattle. Wakeford and her colleagues used Hubble to study TRAPPIST-1g, the 6th planet from the star. They had previously probed the atmospheres of the first 5 planets and found that all these planets lacked massive hydrogen atmospheres that indicate gas giants, making them more likely to be rocky. Their previous study had not been precise enough to determine whether or not TRAPPIST-1g carried its original atmosphere. Just like its brothers and sisters, TRAPPIST-1g doesn't contain its primordial atmosphere. It's got an evolved atmosphere. Only 40 light-years from Earth, TRAPPIST-1 contains the most planets known to lie within the habitable zone of a single star. TRAPPIST-1g is the largest of the worlds, with estimates placing it at around 1.1 times the mass of Earth. If the planets are gas giants, they would retain their original hydrogen-rich atmosphere. In contrast, rocky worlds have the power to change their atmosphere. The movement of carbon can play a key role in the evolving atmosphere. On Earth, trapped carbonate is released as carbon dioxide, a greenhouse gas that allows our planet to grow warmer by trapping heat from the sun. Past research reveals that worlds like Mars and the Moon can also trap carbon-rich material as well as other elements and release them into the atmosphere in gaseous form. The cool temperatures of M-dwarf stars can also cause problems in the search for life. The low-mass M-dwarfs can boast clouds and even water vapor in their atmospheres, much like the largest planets. These molecules can create false signals for astronomers trying to study the atmospheres of the worlds orbiting them. As the planet passes between its star and Earth, astronomers can study the light streaming through its skies to unlock some of the mysteries of the planetary atmosphere. Because they carry water molecules, M-dwarfs can make the process more challenging. It can be difficult to determine whether signals suggesting the presence of water come from the planet or the star. Because the star has these features in it, it means the measurements that you are making, you can be 100% certain that it's not the star that you are measuring. So you have to be able to rule out the presence and the effect the star is having on these planets. To help sort through the mess, Wakeford and her colleagues developed a method to remove the stellar contamination. First, they performed an in-depth study of TRAPPIST-1, examining how the star's temperature changed in different locations. And the star itself is a mixture of 3 different types of temperatures. In general, the star is relatively cool, with a third of it covered in a slightly warmer spots of 2726 degrees Celsius, around 4940 degrees Fahrenheit. Less than 3% of the star is covered with extremely hot spots at a temperature of 5526 degrees Celsius, 9980 degrees Fahrenheit. That's because TRAPPIST-1 is covered by star spots that Wakeford said are smaller and dimmer than those found on our Sun. By studying the star as an individual planet in its system passed between it and Earth, the astronomers were able to examine how the temperature from the star changed. They can actually use the planet as a probe of the star's temperature properties. With that information in hand, the astronomers then examined the atmosphere of the planet itself, confident that they could account for molecular signals coming from the star. They were able to rule out the large, puffy hydrogen atmosphere around G that would have suggested that it was a gas giant rather than a rocky world whose air had been changed by geological and atmospheric processes. That really leads to the true terrestrial nature of this planet. The team also used their measurements to calculate the planet's radius at 1.124 times the radius of Earth, giving it a density just below our planets. This allows to conclude that TRAPPIST-1G is a rocky world. With 6 of the planets out of the way, the astronomers hope to turn their attention to the 7th and final object, TRAPPIST-1H. They plan to study the planet during the summer of 2019. Furthermore, the process that they developed to separate out water vapor contamination from TRAPPIST-1 could also be applied to observations of other M-dwarfs. Isn't it fascinating? Is the atmospheric process on TRAPPIST-1G really natural, or is it artificial? So, who wants to come with me on this planet to find the answer? I've got a rocket to take off soon. Let's go! Before that, thanks for watching. I'll be back really soon. Open your eyes, watch the sky, live long and prosper!